Hi everyone, welcome to the new video. So today we will see example of converting a raw Kubernetes manifest YAML to Helm structure. So let's go. So when we are directly doing kubectl apply -f and we are applying the manifest file. So for we have several environments like dev, prod, UAT. So for each environment, we are creating their manifest file. And when we want to deploy on specific environment, we'll apply that YAML. That is one way. Okay. Another way is instead of creating separate YAML files for each environment, like because there will be some configuration will be specific to that environment. So we cannot if we are hard coding every value like image, so image may be like the image that we have used here, maybe the image used in other environment will be different, it will store different. So it's maybe the environment values, the variables that we are using, the values are different over here, but in other environment it is different. So if we are using this approach of creating of doing kubectl apply directly, then we will have to maintain the separate YAML file for each environment. Now you must be wondering that so what's the problem in this? Because we have a simple YAML file and we can maintain, like if there are two three environments, we can maintain three different YAML files. Yes. But when you actually work in an organization, there are many applications, and their application will have their own environment, uh, and their YAML files are also very lengthy. So instead of maintaining the deployment YAMLs or the Kubernetes manifest YAML different for each environment, we will use a Helm approach. So Helm approach is like creating a common, like we'll create a template of Helm and we will not hard code anything. We'll just create a template of a manifest all the YAML files that we want to deploy. We will not hard code any value. Those values will be coming from values.yaml file, and we will be maintaining the values.yaml file specific to each environment. So in this way, when we do helm install, when we run helm install commands to install the chart, we can apply that specific values.yaml file instead of maintaining that those lengthy Kubernetes YAML for each environment. We can go for helm, which is more better approach, that anyways how many environments will be coming, that helm template, that common helm template is going to handle everything. That's why in organization helm approach is preferred. So as you see, this is a raw Kubernetes manifest file where we have a service first, uh, uh, and then we have a deployment where we have mentioned the replica, how many replicas, what image should container should be created from which image, and the config. Okay, now we will be converting this into Helm. So to convert into Helm, first of all, we should understand the Helm structure. So our Helm structure should have first chart.yaml, which will give that what name our Helm chart should be. Like by which name we should refer this whole Helm template. Like if somebody else also wants to use it, then what chart, this is like a chart. So this chart will have their templates. Inside the templates, it will have its own config map. We are separating each YAML, or you can keep in one, but we can, it's preferred to separate every service or resource that we are going to create, and it will have its own values.yaml file. which is going to override the values inside the templates YAML. And then we have our helpers.tpl. Now helpers.tpl is like a file which can be used where we can write a function, a reusable function, and that function can be called inside our YAML file. So because we are avoiding anything to hard code in Helm approach, that's why helpers.tpl helpers.tpl is also used. So let's go with, first of all, what should be there. Like if we are converting, let's duplicate this. So if we are converting, first of all, deployment.yaml. So first of all, chart.yaml should be created. So how it should be, like chart.yaml. So there are few pointers which are, important in this, that should be there. So API version, like what API version of Kubernetes we are going to use, what will be the name of the chart, and what will be the version that we need to give. So API version, then name of the chart, then description, then type, then version, then app version. You can give. This is the application version. This application version you can give. This is a Kubernetes API version that we are going to use, V2. And when we are going to install Helm, or use this Helm, so we have to give Helm install, then the release name, what release name you want to give, and then the chart name, that will be my app. Okay, so chart name we have to give whenever we are going to do the Helm install, so that it will understand, okay, this is the chart that should be installed. Okay, understood. Then comes um our helpers.tpl. So in helpers.tpl, like first of all, the names, because here we see the names, my app, and my app. If somebody wants to give something else too, that they can give that too. So instead of hard coding, as we are not believing in hard coding anything, we can use these things to get derived my app, this name of the container, the label, or metadata, the config map, from the helpers.tpl. So it can derive it from there. So we follow certain syntax that needs to be understood. So define, this is a function name. My app dot full name, this is a function name which is defined. So wherever you have to use this function, you have to include this my app dot full name. I'll let you know this, but we have to define the function name, then printf release name, like whatever will be the release name. So Helm get installed in releases. Like sometimes, suppose in Helm we have made few changes and we are installing it in our application or in our cluster. Now that is release 1. Now again we have to upgrade it, or install another, like our Helm has been modified again, our templates have been modified again, we have made few changes. Now again, when we again do the installation, we can you know uh, give another release name. We have to uninstall the previous one and install the new one, and we can give another release name. So release name is the releases done for the Helm chart, of the particular Helm chart, how many releases we have done. So that release name, whatever release name, we have to, whenever we are going to do Helm installation, we have to give the release name. What release name will be of this chart? Okay, because that Helm chart is like a package or a public, that if you are creating a Helm chart, it can be used by others too. So that's why maybe release name is different for us, but it is different for another. So that is the approach. So release name, whatever is the release name, it should, if the like if the reason is very lengthy, we will cut truncate, like we will not, we can't. So it is checking the length. It is also checking that trim if there is some hyphen at the end. So because whenever we are using this, suppose our when we say we have to define my app in metadata, so we cannot keep hyphen over there here, okay, or at the end. That is not allowed. So it's just checking, it's just validating that whatever we are going to give, it should not have hyphen and its length should not exceed 63. So this is helpers.tpl. So first we will see values.yaml. So whatever things we see, these values.yaml can be created specific. There will be one values.yaml that will be there. But these values can also be overridden by specific values.yaml of specific environment. You can create like values hyphen dev.yaml. You can override the value. But for now, we have created just one values.yaml, which is going to override the values of YAML defined inside the templates. So we had like Kubernetes, so replica. So we have defined this in values.yaml. So this value will come inside the template will come from values.yaml. Similarly, we have defined the image repository tag per policy. So the image now we have not hard coded, but we have defined in values.yaml. So now the port number also now this will be getting pulled from values.yaml. Service also, service we have defined from uh, so yeah, service. Now this is for image. Now for service, the type, the port, the target port, the type, the port, the target port is defined in values.yaml. Again, the environment. So we have to mention that for which one we have defined, and accordingly we will have to call. Like when we have to call in deployment. Now we'll go with deployment.yaml. Now in deployment.yaml, the name. So the things are same. We have kept this as same over there. Like this part will get copied if you will see API version, kind, meta specification. Only just whatever the things were there. Now we are uh, getting it from values.yaml or the helpers.tpl. Now, name will be, so as I said, this is coming from helpers.tpl. So the function name that was defined in helper was myapp.fullname. So when we have to call that, we have to give uh, two opening brackets, include, then the function name, then dot. So this is the syntax in which we have to include the function that are defined in helpers.tpl. Okay, so name will also come from helpers.tpl. App name will also come from helpers.tpl. Replica name will be coming from values.yaml. So as you see, values.yaml, it has defined replica name and how in which way it has defined it. We'll see and how is it calling. So uh, we are calling it like dot values dot replica count. So, if we see here, so dot values means refer it from values dot YAML file dot replica. So refer this replica one. Similarly, if we have to refer image repository, so dot values dot image dot repositories. Or similarly, if we have to refer the port dot values dot service dot port. So in this way, we have to refer the things. So as you can see, name, image name is the repository name, then dot. So whatever is the repository name first of all, and then the tag. So that's how we have defined in our values.yaml. We can see the repository name and the tag. So both of these things when merged will create an image that we will be using. So image pull policy, like always pull the image even if it is present or not present in the cluster. Then container port, and this is the environment. So you can write, like this. You can write with the functions or range that how it will like ranged $K $V name $K. Like we can so in environment the log level info, like in actual deployment just the log level info. So We have to define it in this way: name and then value info. So that's why it has, some sort of modification is done, that uh, from values.env. So in which way we have defined env? We have defined value here, name over here, and value over. If you see in deployment.yaml, how it is referred: hyphen name log level value info, and we have defined in values.yaml like this, in env log level info. So this is the this will go in name, this will go in value. So that's why the function, kind of function, is written so that the first part is populated in name and the other part will be given value. So this is how we are reading the first of all the values of environment, then we are splitting it into name and value. Okay. Then in service.yaml again, similarly, we are going to copy paste everything from the original. It's just that we are not hard coding any value. So the things will be, changed like accordingly. So again, my app full name, then the service type will come from values.yaml in this way. Similarly, in config map.yaml, again, config map, how the data. So if you see original deployment.yaml, the data has been defined like whatever will go in the data app message, then hello from config. Now if we see in values.yaml how it is defined, app message is a data name and then the value. So just keep like this. So how we will refer it in our config map.yaml, that we have to see. So the thing should be very, properly defined. It should not change also, and our reusability should be also maintained. So this is how, if the this is a way in which we have to write our function. If we are writing any function to get, first of all, the values of config values are picked and then they are splitted, and then how they are defined, like here it will go, the first part will go, then dot, then here the second part will go. So we have, this is a syntax. So in this way we have, created our Helm structure, and then do anything like to after creating the Helm structure, we have to do Helm install. So Helm install, then the release name, then this is the chart name, and this is the application where we are going to do the deployment. And the chart name will be my app, so it will be only the chart name. And then kubectl hyphen n demo get all, and this the uh, after doing Helm installation will verify. And after once the first installation is done, then we can do Helm upgrade, because once first installation is done, whenever again we have to do some changes, we can do Helm upgrade, use a Helm upgrade command. For uninstalling, we can use Helm uninstall demo release, the release name uninstall, and then the namespace name. So this is how the Helm chart is, and this was just a simple example that I've given. There are many complex things where we can try resolve converting them into Helm structure. So that's all.
That's all for today's video. I hope it's helpful. Please let me know your views in the comment section. Till then, take care. Bye.